Hello and welcome. I see our sound is on. I don't know why our intro didn't have sound, but welcome. I'm Matt Dad. This is Science Mom, and we have some shout outs. So some great people watching. I see Isra and Megan.
We have Arushi watching in Seattle, Cookie King 2.0. Hello to Jake and Chris watching in South Carolina. We have Cynthia in North Carolina, Rosalie in Iowa, and it looked like our sound was not working, so that's why I wasn't here at the start. I was trying to troubleshoot that. Glad we have sound.
Too busy panicking, Science Mom. No need. All right. Let us actually look at some of the solutions people came up with.
There were some great solutions in the chat. And hello to Gamer Boy in Georgia.
So I liked this one. I saw 2 times 5 all times in parentheses 3 minus 2. So that was Rosalie's solution. I like that because 2 times 5 is 10 times 1. Yes.
And Arushi had that solution too. That's a great one.
That is actually the same solution that I came up with. Did all the solutions actually end up being equal to that? It looks...
Actually, I was wrong. Arushi's was a little different, but multiple correct solutions in the chat. Give yourself a pat on the back if you figured this one out.
Yeah, the warm-up probs, got to get the blood flowing because today we are talking about decimals. And so for those of you who have never messed with decimals before, this will be an introduction, although we will get in there pretty far. We'll even be doing some arithmetic with decimals by the end. So we're trying to figure out what they mean. And it turns out, I bet none of you are actually new to decimals because I bet you've dealt with money before.
And you're saying if I know how to use money, I know decimals?
You definitely know something about decimals if you know how to do money. So if let's actually write that out. So what do decimals have to do with money? Well, you could have some money. So we usually put a dollar sign in front of money. That's money specific. That's not just for decimals. But something like 3.14, that's $3.14. Okay, so it's the American currency, but most currencies are going to work this exact same way. So typically, we deal with whole numbers, and that's what we're comfortable with. But, you know, that 1/4, that 14 cents, that's not a whole number of dollars. That's a fraction of a dollar, and that's what we want to talk about. But first, let's actually talk about the idea of place value. So if I wrote out the number 5,280, Science Mom, what is the fives place? What is that representing?
And see if you can answer out loud before I do if you're watching the recording. It's the thousands place.
That's right. So that 5 is really for 5,000. All right, so I'm just going to write that out. That's our thousands place.
Yep, and Luna Lovegood and Chris and Avery have all got this in the chat.
Good. All right, let me know, chat. What about the 2? The 2 is indeed the hundreds place.
Nicely done.
The 8. The 8 is the tens place. Very good. Everybody knows this, it seems like.
Awesome.
And the 0 is the ones slot. All right, so 5,280, if we were to count long enough, starting at 1, 2, 3, 4, we'd eventually get to 5,280. But we wouldn't get to 3.14.
We wouldn't, because we're just taking steps on whole numbers.
That's right. So we're not hitting the fractional part, but can we go a fraction? So I did 5,280 because that's the number of feet in a mile. But could I go a fraction of a foot?
Yeah, you can just inch forward.
Yeah,
like
sure.
A tiny little step.
Inches are fractions of foot. They're 1/12 of a foot. But yeah, you bet you don't have to go whole numbers all the time. So the thousands, hundreds, tens, ones. Well, what's smaller than ones? What's the next digit over?
Oh, this is a good question. What's smaller than ones? Well, is it a tenth?
It is 1/10. So you're seeing a pattern there, Science Mom, where we're dividing by 10 each time.
Oh.
Because, yeah, I didn't write it this way, but yeah, here we had 1,000, here we have 100, here we have 10, here we have the 1 slot.
And good job, Megan and Luna, and they're seeing so many tenths filling up the chat.
And then after that is the 100ths, so 0.01, or if you're thinking about dollars, then we're thinking about kind of like cents. So how many cents are in $1, Science Mom?
100. 100 pennies make a dollar.
And in fact, that's where the name cent comes from. So you got this, what was it? It's got to be a Latin prefix, like the word century has to do with 100 years. So that's 100 cents in a dollar. Okay, do we have money that represents the tenths?
Yeah, dimes.
Dimes. Okay, so in this case, we can think of pennies and we can think of dimes as actually representing those place values. The next digit over, we'd have dollar bills for the 0. Here we'd have $10 bills, $100 bills, $1,000 bills.
So this is a nice little trick, Math Dad. You're telling me that if I'm working with a decimal problem and I maybe get a little confused about what means what, I can think about pennies, dimes, and dollars, and that will help me out.
Absolutely. Now, one more question before we dive into our exercise or activity. What about, can I go over another digit?
Ooh, what do you think? Type it in the chat if you're watching live, or see if you can answer before me if you're watching the recording.
Okay. So we got the tenths, the hundredths. Does it go even further? Because, you know, I've never gone to the store and seen a third digit. Actually, maybe at the gas station I have. Okay.
Yep, Megan and Avery have it.
Gamer
it's
boy.
the
Yep.
thousandths.
Yep.
Good job, everyone.
Good job. Yes, so you can go to the thousandth place, and that's at the gas station pump you often will see that they're rounding it. They're trying to make the number seem smaller. So, for example, you go to the store, they'll have a sale, and instead of saying $18, they'll say only $17.99 because that sounds way smaller.
But it's pretty much $18. It's closer to 18 than it is 17.
That's right. But the gas pumps do the same thing. Okay, we are going to do a Desmos activity. So if you look down in the video description, you will see this link, which will allow you to join the activity and take part. So,
this link right there.
You want to open this up in a separate tab, and that way we can share what we're doing, but you will also be able to participate. And even if you're watching the replay, go dive in and you'll be able to see this. So here's Science Mom's screen of this exact activity. And thank you, Science Mom Amber's even pasted the link in the chat. So kudos, go team. All right, so look at this warm-up challenge. Science Mom, this is 60 plus, what number equals 100? I'm gonna have you hold off for a moment because I want everyone to have a chance to answer this. But if you get it right, you get rewarded with another problem. But so give everyone a moment. There's actually a good chance that your problem will say something different than this one.
Oh, Gamer Boy and Isaiah have my back in the chat. They know what the answer to this is. They've told me already.
40.
But you're telling me that in Desmos, different people might have different questions on their screen, but they'll all be similar to this?
That's right. So let's hit the try it button and let's see if it worked. 60 plus 40 is indeed 100.
I thought you said we were doing decimals, Math Dad, because this is just addition and subtraction.
That's why it's a warm-up. You're ready to dive in and face the challenge head on, but we're doing our planning warm-up. You gotta stretch before you work out, Science Mom.
Okay, so we're stretching.
All right.
37 plus what number equals 100?
Oh.
Now, 40 plus 60 equals 100, so if I'm going to go from 40 down just 3, then I can just take that 3 and add it to the 60. It's 63, right?
So you're saying the answer was 3 more than the 60 last time because the 37 is 3 less than the 40?
That's right.
You're noticing kind of an interesting symmetry balancing those two?
Also, I trust the chat. And Shaguta and Melissa and so many other people said 63. I trust them that they know how to do addition and subtraction.
Oh yeah? Well, what about this one? 350 plus what number equals 1,000?
Ooh.
The numbers have grown larger. That means your fall will be so much bigger if we fail on this one.
Well, 300 plus 700 equals 1,000.
Jehu, Arushi, Avery, Gamer Boy, they're all saying 650.
That's right, because I added that. 650 plus 350 equals 1,000.
So I was hoping everyone would try some of these on their own, but I think maybe they're so fast, maybe they're doing that and answering your question, Science Mom. All right.
I think they are.
One more, and then we will be truly warmed up and ready.
So with this warm-up challenge, can I do as many as I want, and then when I feel ready, I go to next?
That's right.
That's how it works?
Right, except I have it locked so nobody can advance because I didn't want to spoil the surprise. All right, so what plus 205 would equal 1,000? And
I'm seeing lots of 795s in the chat, Math Dad.
okay, so how do you think they're coming up with those numbers, Science Mom? Because clearly we've got some students who are really fast at getting it, but my guess is not everyone is able to do it quite so quickly or efficiently. So how would you come up with that 795 number?
Well, I could take 1,000 and minus 205. But I could also look at 205 and say, okay, if I add, if I add these two together, 5 plus 5 is 10, and then 9 plus 1 is also 10, and then that gets me another 1 in the 100s place, so now I have 1,000.
Okay, so once you see the answer, it's much easier to check to see if it works.
That's right.
Okay. My guess is that there were a variety of strategies employed.
I love Isra's comment here. 205 plus 95 plus 300 plus 700.
Okay, I've got to break that out. We've got to take a look at that because that is brilliant. So if we started with 205, the question, Isra said, well, let's try to get that up to a round number. So we first added 95 because that was 300, and then added for 300 up to 1,000. Well, that one's a much easier calculation. Let's add 700, and altogether that would give us 1,000. So we had to add 700, and we had to add 95 altogether. That's 795. I really like that strategy.
Brilliant.
And I guess a third strategy I was going to propose is maybe kind of just start guessing. It's like, well, 200 plus 800 would work, but that's too big by 5. So just lower the guess by 5. So instead of 800 would be 795. But yeah, so lots of great strategies there, and I'm...
And look, the sun came out and is happy because we did our warm-up and it was great.
It was. I am impressed that we got through it so quickly. The calculations, you guys are on the ball. Go team. All right. Let me unpause things here, and I'm going to let us advance to the next couple of screens so that we can do an activity here. I feel all powerful because I can restrict what screens
you get
people
to decide
can
which
actually
screens
go to.
Are unlocked unless you're watching the recording, in which case all the screens are open and Math Dad has no power.
Oh, that's true. Okay, so now we have this big square. If you count it out, you'll see that it's 10 by 10. So for a total of how many squares, Science Mom?
100, because 10 times 10 is 100.
That's right. So that entire square represents 1 unit. And you could think of it if you want. You could think that's like $1. And then how much would each of the little squares be? If the big square is $1.
The little squares would each represent 1 penny, because 100 pennies makes $1.
That's right. So in this question, show that 0.45 by entering some quantity of tenths, hundredths, and or thousandths. And on this one, there's not a unique answer. It turns out there's more than one way to do this, but we'll discover that. But when you look at this one, Science Mom, actually, never mind. We're going to have 30 seconds of silence while they all answer it themselves. Then we're going to do it. Sorry.
Okay. Give it a try yourself before I do it. Do we have a countdown?
I don't have a 30-second countdown ready. And my countdowns are too long, so...
If someone skips forward to this point in our video, they'll be really confused. Why is Science Mom holding up her hands and counting down?
Okay, so let's actually see what some of the answers were here. So Arushi and Gamer Boy and Luna Lovegood, Isaiah, they're saying that 4/10, 5/100, and 0,000ths would work. So let's try their answer, Science Mom, and see if it works.
Good job, Emraya and Liam as well.
Well, let's see if it works before we congratulate anyone.
It looks good to me. And then 0 here. So I'm going to try it and see what it looks like.
Okay.
There's my 4/10. There's my 5/100, and a little check mark to say it's correct.
Ooh, so I like that. You see how there are 4 columns that kind of came in? So that if you only cut the square into 10 columns, those are the green columns, and then those little squares. Yeah,
Okay,
I like that.
I want to experiment. What if I do 3, and then what if I do a bigger number here? Can I go bigger than 10? Can I do
Try
12?
it. Yeah, let's give it a try. So with, well, 3/10 and 12/100 actually
It
work
filled
out.
up the whole thing.
Ooh, but we only got 0.42, Science Mom. So what adjustment do you need to make to your answer?
Lots more purple.
You've moved on?
Well, I want to see if I do 1/10 and 35/100, can I get my little chart to be mostly purple? Why, yes, I can.
Okay. Well done, Science Mom. So that's actually what we're supposed to be doing on our next few screens. We're going to play with this a little bit because it turns out there are other ways of doing it. And now look at this. Science Mom is actually busting out the thousandths.
Oh, they're so tiny.
They are super tiny. Look, it takes a lot of thousandths to fill up the whole big square. It takes 1,000 of them. But we still didn't quite get the right number. And that's okay. Sometimes it's just as fun to fail on these problems as it is to get it right.
I want to see 1,000 thousandths filling up the whole screen. There we go. Look at it go.
You did it. but it's not the right answer. We're supposed to be 0.45.
I want to give a quick shout out to Weston, who solved this by using the tenths and the thousandths, but not the hundredths. So there are multiple ways to do it and to do it correctly, which is pretty fun.
That's right. So that's what screen number 3 is asking you to do. See if you can come up with a different way, and I want to spy in and see what interesting things people have come up with. Because I know definitely multiple ways of getting it. Some people are using all thousandths, like Rosalie managed to get 0.45 just using all thousandths. How many thousandths, Science Mom?
How many thousandths if we do it with all thousandths?
If you do all thousandths.
Then we need to do 450, is that right?
Give it a try, let's see.
I'll give it a try and see. Woohoo! I did it just like Rosalie. Can I do it again?
Right. Yeah, go ahead.
I see. Ooh. And Maria did it with just the tenths. So will it accept decimals here if I just do 4.5?
Malachi.
Awesome!
I don't think you were supposed to do it that way, but yes, that's very clever.
Or no, it was purple, so it was just the hundredths. So let's see.
Oh. So you were the naughty one, Science Mom. But
there are lots of different ways to do this. This is fun.
That's right, and if you don't write anything, it just kind of counts as a 0, right?
And then you can do different combos, right? Your screen doesn't have to be all green, all purple, or all red.
Let's try Avery's suggestion of 1, 15, and 200.
All right, so 1/10, 15 hundredths, and how many thousandths?
200 thousandths.
200 thousandths. Let's see what it looks like.
The word thousandths sounds a lot like thousands. Sorry about that.
Ooh, nice job, Avery. I like this one. Yeah. It's very aesthetically pleasing with its balanced colors.
It is, and it almost makes me wonder, is it possible to balance them entirely, to have equal size of colors based off of all 3 columns? So that's a challenge that I will offer there. So we started off, Science Mom, by asking about numbers that added to 100 or that added to 1,000. Any idea why we would talk about that on a day when we're dealing with decimals?
Because we have a base 10 number system. So that's how we use our numbers, right?
That's absolutely accurate and right. But also, though, if you look at the gap, the white region, would be kind of asking the same question. How big is the white region? Well, we'd be asking, well, what plus 0.45 equals 1? And often this idea of what's missing will be just as useful in our calculations as what we have. So, oh wow. So, are you trying to solve Science Mom?
I'm trying to listen to what you're saying and respond, but I'm also really intrigued by this divided equally into 3 parts question.
So look at Megan's solution in the chat. Megan said do 1.5 tenths, 15 hundredths, and 150 thousandths.
Ooh, I like it. I think this is really promising.
So ones and fives in all 3. And if you look at that, we got 3 regions that are all the same size. So kudos, Megan. It's kind of cheating because we had to use a decimal as the tenths, but I like it. We had to be devious if we wanted to get that to work. So excellent job.
And I want to say, if you are watching the recording, it's perfectly fine to pause and take more time on these questions.
Okay, so up next, we're going to jump over to screen number 4 and screen number 5, and we're going to try to identify a number. So before we were given a number and asked to figure out how to write it, now we're given an image, so we're seeing what fraction or what portion of that whole square is filled, but what's the decimal?
Oh, all right, so now I've got a square. I know each square represents 1 penny, essentially. And then you're asking me how many are filled.
Yeah, what's the number there? And if your number doesn't have a decimal in it, you probably want to take another look, because it would be easy to try to give a whole number answer, but the answer is not a whole number. And then once you've finished this one, we're going to give you a minute to think about it. Go ahead and go on to the next screen where there's some sorting that you're asked to do, a card sort.
All right, we'll have a minute to work.
I only made 3-minute timers, Science Mom. I need to make shorter timers.
Are you telling me we're not muted?
Yeah.
Oh, okay. "20 more seconds to put in your answer. And again, you can always pause the video if you want a little more time. All right, Math Dad, I think we're ready.
All right. I want to give a shout out to some of the students who got it right. Arushi, Cynthia, Emrea, 7G, Avery, Isra, Joseph, and Nico happened to get it exactly right. Now, Science Mom, what do you think the answer is?
Well, the first thing I thought of was our example right at the beginning where we said that the ones place and then a decimal, then we go in reverse. So then we have the tens and the tenths and the hundredths. So I'm going to have 0 because this is less than 1, 0 point, and I have 3 full columns. Those are my tenths. And then I need to count, okay, how many squares do I have right here and right here? I have 2 of them. So 0.32, and then I could submit it and I can explain my thinking. I'm just going to write money because the money example really helps.
Because you were thinking of those columns as dimes?
Yes, so I was thinking how many dimes do I have and how many pennies do I have, because the dimes are my tenths and the pennies are the hundredths.
Nice. Yeah, I like that way of thinking about it. All right. Then, so money, money, money. But yeah, putting into words what you had said out loud, though. You look at the columns, those are the tenths, the individual squares.
So that example helped me remember.
All right, jump over to the next screen, and you get to see the card sort. You're supposed to group things together that are equal. So it might be just worded out, it might be a numerical value, or you might see a picture. Only group them if they are equal.
Ooh, so like this right here, that's half filled in, so that goes with 0.5 because 0.5 is half.
That is correct.
Now they're grouped.
Nice.
Real fast, Math Dad, I have to ask, what is diagram B and C over here? Is that other ways I could do it?
That's correct. So each of the diagrams do show the same number. Yeah, sorry, we jumped ahead so
other
much.
ways to think of it.
Right, and then, but would they all be written 0.32? So that's an interesting question, because before, didn't we just say you count the number of full columns with the green shading, and that would give you your tenths place, and then you count the number of little squares, that gives you your hundredths place. But here, we're using totally different colors. Do we get the same number? Or is there some different way we should be writing the number because we colored it differently?
What do you think? Type the answer in the chat or answer out loud if you're watching the recording. I think it's the same, Math Dad, because that would still be 0.32.
So,
am I right?
So, wait, even if it's purple, it should be the same as if we colored it in differently?
it would still equal 0.32.
Yes. So you are correct. And one interesting thing Science Mom just did out loud, she called it 0.32, and then the next time she called it 0.32. And you'll actually find that sometimes we're just lazy and we leave off the 0 in front. We just say, it's 0.32, and you just kind of have to get used to it. That is, humans are lazy, but they mean the same thing. But kudos, Science Mom, gold star, you are correct.
Yay!
And those of you in the chat that are saying it is the same, regardless of what color we use, you are right, because the same number of the little squares got shaded.
Good job.
All right, I want to give people a minute to work on this card sort before we go ahead. So we will be quiet for 60 seconds, and we'll peek in and see what you're working on.
Math Dad, I'm seeing lots of I'm already done in the chat. And when I look at the message board, a lot of you have already matched everything up. Good job.
That's pretty good, although I'm actually seeing a lot that are still working on it. So
Yep. If you're still working, that is completely fine. And remember, if you need more time, you can always pause the video to take a little more time.
all right, Science Mom, let's give it your best shot here. So
All right, I am ready. Next, I'm going to do the 0.35 because that's familiar to me because we just did it in a practice exercise and I recognize it. There it is, 3/10. Oh, come on, stick together. 3/10 and 5/100.
ooh.
I just said it out loud as I was describing this, so 3 of those, they all go together. Whoops. Can I drag the whole thing? There we go.
Yep. All right.
Now, 4/100 and 10,000ths. I don't see. Oh.
Ooh, so the hundredths are the little tiny purple squares.
That's right. So 4/100, that's just these purple squares, and then 10,000ths or 10,000ths together, that equals 1/100th.
Those are little tiny red rectangles. They're so tiny that you can hardly see them on the screen.
Go together.
Kudos.
And that's the same as 5 of the hundredths, which would be 0.05, and then 50/100ths. Oh, 50/100ths would be the same as 5/10ths.
Excellent.
So that is my solution here. And now, can I break these apart?
You can break them apart. Oh, you want the
I want the picture to all
picture
be
on
on the top.
All right. So drag the picture up.
Whoops.
Just click on it and drag it. It'll work.
There
All
we
right.
go.
It's got to be aesthetically pleasing for Science Mom.
It does. Well, we've got to be organized. Now I'm sounding like you, Math Dad. You're usually the one who wants things to be organized.
Well, when it comes to math, having things organized will pay off. Oh, here we go. So, Science Mom, when you hear the word 50/100ths, and I know it took a moment to figure it out, and I just want to remind us, 50/100ths is exactly the way that we would read that fraction. 50/100ths. Or anytime we do a fraction, we kind of throw that THS on the end of things, or 5/10ths, ooh, or 1/2. So that would have been another way to think about it. So if you're familiar with fractions, if your fraction kung fu is strong, then each decimal, each part of the decimal, each place value represents some fraction. And
So I feel like what you really just told me is that 0.5 is the same as 0.50, because that would be 50
yes,
hundredths, right? And this would be 5/10ths, but they're the same.
they are the same. And that is one of the biggest mistakes students make, is to try to think of those as different values. Or if you ask, which is bigger, 0.5 or 0.46? So which of those two decimals is bigger, Science Mom? The one on the
Which of
left or
those
the one on
is
the right?
Bigger? Ooh, weigh in the chat, give a vote, type in the one that's bigger in the chat. 0.5 or 0.46?
Yeah, well, one of those two decimals is bigger than the other, but which one is it? And
Luna says 0.5, so does Bethany.
Yep.
And you were correct,
So
because if you think of our little graph here, think of the 0.51 where you have half of it completely covered, and think of the 0.35. It's smaller, right? And 0.46 would also be not quite half.
Right, so this is like saying 5 columns shaded, or here, 46 of the little squares.
Yeah,
Well,
or 4 columns and then 6 of one column.
that's right. So that will help us to remember. So I like your trick there, Science Mom. So if we started with 0.5 and we wanted to compare things, then what we might do is just add a 0 at the end of the decimal. Because now I think everybody would get it right on the first try.
That's right.
You probably wouldn't even have to think that much. You'd know which of those two numbers was bigger.
50 is bigger than 46.
Yep, I'm loving the observations in the chat. The 4 is less than the 5, and that's the number of columns that were filled. Good job. All right, then it is time to move on.
They're ready for the next one to be unlocked, Math Dad. I'm seeing some requests in the chat. Unlock the next one.
Matt, that's too slow. All right, I'm going to give you 4 screens this time. Screens
Woo.
6 through 9. And I'm actually going to put the 3-minute, I'm going to put what time we have? I'm going to put the 4-minute timer on, and I'm going to turn off our sound.
Wait, first, can you show them my screen? Because I got it nicely organized. It looks really good.
Oh my goodness, Science Mom got
Ta-da!
it right.
Look, we have the visual representation, and then we have the written out with words, and then we have the decimal. It's very lovely.
All right, so without any introduction, attack. Screens 6 through 9, just get down what you can. Okay, I am impressed with the number of students that got this right. My guess is many of us have seen the decimals before. I think we'd get it, but we got it really fast.
And if you were watching my screen, I was experimenting by putting in different numbers. So I tried, okay, 2.7, and I've got 0.13 that I'm adding in as well. You know, should I just add them together? I could add the tenths. 2 plus 1 is 3. I could put 3 here. And then I could add the hundredths. 7 plus 3 is 10. And I can write 10 here. I can see what that looks like. I tried several different versions, but my favorite, just because the colors looked nice, was to do it this way.
So Science Mom, you're putting in decimals in our answer. Definitely complicating things a bit, although you know what? I didn't say it wasn't allowed, did I? So how would we actually go about adding these up? Well, the secret to doing this was, as I saw some people say in the chat, the 0.27 means that's 27 little squares. The 0.13 means 13 little squares. So we're just saying, well, 27 squares plus 13 squares is 40 squares. So how do we represent 40 squares? Well, 0.40. So the answer that I was expecting, Science Mom, to write was to put a 40 there, maybe even nothing there if we want, and oh, it didn't.
Oh, no, it's going.
Oh, yeah. Yeah. So, but either way, we got the same answer, and...
That's right. And Rosalie points out we could do 400 thousandths if you would prefer this block to be red instead of green. There are multiple ways to represent this.
Excellent. Okay, Science Mom. And so we wrote it as a decimal. We said it was 0.40. Now, my question here is, would everyone's answer look the same? Go ahead and hit share.
When we write it as a decimal, everyone's answer should look the same because if you add this up, that's what you will get.
Yeah, there's a unique representation, I should say, almost unique. There's a slight technicality that we won't get into there. But yeah, you're not going to find multiple ways of writing the same number.
But you can break it apart multiple ways. You could say this is 4/10. You could say it is
40
400.
hundredths.
Yeah, 400 thousandths. There are lots of different ways to break it apart.
That's right. And then what about subtraction? Because we got 0.2 minus 0.11. How would we possibly visualize that one?
Ooh.
So Science Mom, you didn't even try this one yet.
I didn't try this one yet, but I looked ahead and I said, aha, it's a little easier to think of this as 20 minus 11 than it is 0.2 minus 0.11. And 0.2 is the same as 0.20.
Mm-hmm. So you're saying the 0.2 means that's 2 full columns minus, and then the 0.11 is just 11 squares. So 2 columns minus 11 squares.
That's right.
All right, and what was your answer? Go ahead and enter it.
My answer is 0.9.
Ooh, not 0.9. That's not what you said out loud.
Oh, whoops.
It was 0.09.
That's what I meant to say.
Ooh.
And it is okay to make mistakes while you're learning.
It is. I make them all the time, and I'm supposed to know this stuff. Yeah,
there we go. This looks much better.
Yep, 2 columns minus 11 squares equals just 9 squares. So 0.09 is our decimal there. 9 100ths.
That's right. And shout out to Nomad Academy and Isaiah and everyone else in the chat putting in that correct answer. Good job.
All right, and then, all right, Science Mom, can you do this one? 0.203 plus 0.105.
Ooh.
Or that's...
I can. So I'm going to start with this furthest place value, the thousandths. 5 thousandths plus 3 thousandths is 8. Then I'm going to move my cursor over. 0 plus 0 is 0. I don't have any tenths. Move it over one more time. 2 plus 1 is 3. Whoops, that was not a 3. I did that kind of a funny way, and if you want to write it out on paper, that is a good way to do it as well.
So looks to me, Science Mom, like you basically just said, let's do 203 plus 105.
That is what I did.
Yeah, and so in that case, you were adding the thousandths, and if we were to write it as 2 fractions, that's exactly what we would see. Now, we didn't pace things very well here. I'm going to unpause and let you examine the other screens, but there's not a lot of time. So on screen number 10, So I want us to try to describe in words, how would you determine the value of 0.4 minus 0.15?
Real fast math, Dad. Someone asked, how do you finish number 9? It's just endless questions. So good, thanks for pointing that out, Megan. You can get as much practice here as you'd like. So I'd say if you answer and your answers are not correct and you have to kind of try a few times before you get it, then do several of these for practice. But if you feel confident in these, you don't have to keep going. You can just hit next.
That's right. We'll never run out of numbers, so that screen will never run out of problems.
That's right. Describe how a diagram can help you determine the expression like 0.4 minus 0.15.
I'm sorry, I didn't.
Oh no, did you not unlock the screens, Math Dad?
They're unlocked now, sorry. Go to...
Thank you for letting us know.
Whoops.
All right.
Yeah, but putting these into words. So we...
Normand Academy and Emrea, let me know, what did you put here? Put some answers in the chat for me. How can I express this using this diagram?
Because I think there will be students who can actually get the right answer here, but that would really struggle to put it into words. So that's what this challenge is all about, is describing the work.
So I'm using this little sketch tool here to block off 0.4. So that's, since it's the tens, 0.4 is the same as just 4 of these columns.
Mm-hmm. I like it.
And now I need to take away 0.15.
So how are you going to do that?
So I don't think do I have another color that I can use? Oh, I can. So with the purple here, I'm going to put a line down. That's 0.1, but 0.1 is not enough. Now I need to do the 5.
The 5/100ths.
Which is kind of like at the beginning, remember we talked about pennies? There's 1, 2, 3, 4, 5.
Okay.
So then everything that's left, that is my answer.
That's right, and...
This looks like some sort of big, like, spaghetti monster.
So I really like the way you framed that, Science Mom. You said you thought of it as 40 pennies minus 15 pennies, essentially. Mm-hmm. And that's actually math that you could have done long before we got to today's lesson on decimals. But it was just realizing that those decimals are the same, giving us the same question as we would get if we were dealing with dollars and pennies in this case.
So for an explanation, I could say 40 pennies minus 15 pennies. Would that be...
Sure, but then you'd have to then make sure you got the decimal in your answer, because someone might say that's 25.
That's right.
But the pennies are 0.01 each.
I like what I'm seeing in the chat here from Emrea. So 4/10 columns is what you start with, and then you need to take away 1/10 column and then take away half of another 10th column.
Perfect.
That's a great way to describe it.
Great. All right, we have gone over a little bit, and we want to be good with the time. So I will challenge you to do the next question on your own, although I think for the cool down, we're probably about there. But then I'm curious, how well did you understand the lesson, and how did you feel about learning math today? So you've got lots of options that you can select here, and just be honest, and that's good feedback for us, because yeah, we'd love to know what made sense, what didn't make sense. And for some of you, this was review. For others, it was something new. But decimals are going to be a big part of your life, whether you like them or not. And I hope that we all learned something today, and that we'll remember that when you're thinking about decimals, if you're getting confused, try to think about it with dollars and cents, because that's something that you already have a lot of connections with in your head, and your intuition's probably pretty good there.
That's right. And Cynthia, yes, you can definitely draw on the screen in that previous one. And if you're feeling like this, like, or, oh boy, I'm not sure, those questions like number 9, where you could just practice over and over again, you can just click back and get some more practice till you feel more comfortable. I'm going to pick the green smiley face Math Dad, mostly because it was so fun to see all of you. Thank you, Science Mom Amber and Emrea and Sebastian and so many others for joining us. And I am glad that we could work on some math today.
Work hard, grow smart, and we'll see you next time.